Video we are going to cover conservative field, Stokes theorem and example. So the curl of vector field f is equal to mi plus nj plus pk is defined as curl f del cross f. The first row you have to write ijk of the determinant, and then in the second row del by del x, del by del y and del by del z, and the third row you have to write m and p, and then solving you will get this. If f is a, then you will get this is the value of curl of f. Then conservative vector field, if f is a conservative vector field, then curl of f is equal to 0. So we'll see one example. Determine if the vector field f is equal to 6xi 2y minus y cube j and 6z minus x cube k is conservative or not, we have to determine. So write the curl f is equal to determinant of this, and then evaluate the determinant. So when we evaluate the determinant by putting the value of m, n and p here, we will get del cross f is equal to 3x square j, which is not equal to 0. Since curl f is not equal to 0, the vector field is not conservative. And if it is equal to 0, then the field is conservative. Then a statement of Stoke theorem, let S be a piecewise smooth oriented surface having a piecewise smooth boundary curve C. Let f is equal to mi plus nj plus pk be a vector field whose component means m and p have continuous first partial derivative on an open region containing S. Then the circulation of vector f around C in the direction counterclockwise with respect to the surface unit normal vector and equals the integral of the curl vector field del cross f vector over S. Means mathematically we can write f dot dr, integration of f dot dr along closed curve C is equal to double integration del cross f dot n vector d sigma. So the figure says the orientation of the bounding curve C gives it a right-handed relation to the normal field N if the thumb of a right hand points along N, the finger curl in the direction of C. So this is the direction of N and this is the direction of curve. Conservative field and Stoke theorem. If del cross f is equal to 0 at every point of a simply connected open region D in space, then on any piecewise smooth closed path C in D, integration f dot dr along closed curve C is equal to 0. So examples, evaluate double integration del cross f dot and d sigma by Stokes theorem for the field f is equal to yi minus xj over the hemisphere x square plus y square plus z square equal to 9 and z is greater than equal to 0. Solution, given f is equal to y minus xj by Stokes theorem, we have double integration of del cross f dot and d sigma is equal to integration f dot dr along closed curve C. Now C is a circle, x square plus y square equal to 9, z equal to 0, which is the boundary of the hemisphere S. The parameterization of C is given by vector rt is equal to r cos t, this is the value of x, and 3 sin t, this is the value of y, and z equal to 0. And where t lies between 0 and 2 pi, substituting into the equation f of rt dot dr by dt, will get we'll get minus 9, and then putting all this value in this formula, we'll get final answer as minus 18 pi. Next example, use Stoke's theorem to evaluate double integration del cross f dot n dr, where f is equal to x square I minus 3xyj plus x cube y cube k, and s is the part of z equal to 5 minus x square minus y square above the plane z equal to 1. Assume that s is oriented upward. So solution, in this case, the boundary curve C will be where the surface intersects the plane z equal to 1, and so will be the curve 1 equal to 5 minus x square minus y square and x square plus y square equal to 4 at z equal to 1. So the boundary curve will be the circle of radius 2 and the plane z equal to 1. The parameterization of the curve, vector rt is equal to 2 cos t I plus 2 sin t j plus k, where t lies between 0 to 2 pi. So by Stoke theorem, we will use this formula. Then we can write here integration 0 to 2 pi f of rt dot dr by dt into dt. So calculating all these value and finding dot product, will get this, and put this value in this formula, will get the answer as final answer is 0. Next example, state Stoke's theorem and use it to evaluate double integration curl f dot n d sigma, where f is equal to xyi plus yz j plus xy k, such that S is the part of a sphere x square plus y square plus z square equal to 4 that lies in the cylinder x square plus y square equal to 1 above the xy plane. So given f is equal to xzi plus yzj plus xyk, surface S is a part of sphere x square plus y square plus z square equal to 4, inside cylinder x square plus y square equal to 1, and above plane x equal to xy. By Stoke's theorem, double integration del cross f dot n d sigma is equal to integration f dot dr along closed curve C. So we first compute curl in this way. So this is equal to yi minus xj. Now we evaluate the line integral over the boundary curve C. The boundary curve C is the curve of intersection of x square plus y square equal to 1, x equal to y, and x square plus y square plus z square equal to 4. So from x equal to y and x square plus y square equal to 1, we get y is equal to plus minus 1 by root 2 and x equal to plus minus 1 by root 2 and z equal to root 3. So the boundary curve is the circle x square plus y square equal to 1 restricted to x greater than y. We parameterize the curve C as vector rt is equal to cos ti plus sin tj plus root 3k, where t lies between pi by 4 and 5 pi by 4. So parameterizing f, will get cos t root 3 I sin t root 3j and cos t sin t k. Then we'll find the del r by dt, and then we'll find the dot product of f and dr by dt, and then putting all this value in this f dot dr, will get the value of integral is equal to 0. So double integration del cross f vector dot n vector d sigma is equal to 0. This is the final answer. Thank you. Link of PPT is given in the description box.